Hello everyone. So this short video on the grid generator app for Collect Earth will guide you through the process of generating a grid for your Collect Earth project. So before starting, I will make a little introduction on the Collect Earth system overview. We see that Collect Earth system has different components. The user is interacting with Collect Earth, which is a tool that enables data collection through Google Earth, Bing Maps, and Google Earth Engine. And it is designed so that users can analyze high and very high resolution satellite imagery for different purposes and at different scales. On the other hand, we have Collect, which is the survey designer and provides a fast, easy, flexible way to set up a survey with user-friendly interface. Then we have the grid generator, which is a Google Earth Engine app created with the Google Earth Engine code editor. And this tool allows to design and generate a grid for your Collect Earth project. Okay, now we will continue talking about the grid generator app developed with Google Earth Engine that has the form of a website, as you can see. And we will explain the different options that this tool is offering. For the generation of a grid for your Collect Earth project, you have different possibilities. So on the one hand, you have option A and B. Option A would be to generate a grid with plots within a specific country that you can choose here. And then you can set up the province and the district. Option B will be to develop the geographic, to delimit the geographic area, uploading a shapefile or a polygon. This will be this option, use feature collection, Google Earth Engine public asset. In order to delimit the geographic area with your own shapefile, the user needs to upload a shapefile to the Google Earth Engine as an asset. I will explain this later. The newly released option, which will be option C, will be to use a polygon or rectangle drawing tool in order to make manual selection of the area in which you want to work. You have a small area in a certain territory where you want to work. You can just draw the area yourself and select the rest of the options in order to generate the grid. After delimiting the geographic area of your project through either administrative boundaries, defining a country, if you want to work on the country level, province or district, or on the other hand, uploading your own shapefile, there are a few more options that need to be defined in the app in order to generate a grid. First of all, we need to define the coordinate system. You need to set the APSG code for the coordinate system that fits best in your study area. For large countries or countries close to the equator, we recommend to use the APSG code that is predefined. With this coordinate system, the longitudinal distance between plots changes the more you move away from the equator. So you may need to use another projection that fits better in your area of interest so that the distance between the plots on the systematic grid is constant. In order to find the coordinate systems that better fits to your area of interest, you can visit this website, apsg.io. The second option is that you can add different data to the plots of the grids that you are going to generate. For example, you can add the GAUL administrative units data, such as the country, province, or district. You can add the digital elevation model with data such as elevation, slope, aspect, or you can add IPCC data specific for greenhouse gas inventories that include soil, climate, etc. Different kinds of data. With these options, you can improve the information contained in the grid that will be used during the analysis phase of the data collected with Collect Earth. The next option will be the kind of grid that you are going to generate. You can generate either a systematic grid or you can generate a random grid. If you generate a systematic grid, you set the distance between the plots in meters. And this will be always the same distance between the plots. So we recommend more than 500 meters. This depends on the magnitude of your grid. If you work at country level, you may work with more distance. If you work at district level, you may shorten the distance between the plots, depending on how you design your grid. In the random grid, you set the number of plots that need to be generated in the grid. And you can include here the number of plots. Lastly, what you can do is to add columns on the grid CSV file from other shapefiles. This is useful when you want to have ancillary information on the grid for later use in the analysis or for stratification. These shapefiles must be uploaded to the Google Earth Engine as assets, and this option will add all of the properties from the polygons to their intersecting plots. And after having defined all these possibilities, you click on Generate Grid, and the grid will be generated. Now I will show one example on how delimiting the geographic area of a grid, choosing a country, province, and district. So first of all, I will select the option, I will select the country, Spain. I will select the province, Andalusia, and the district, Cádiz. The world geodetic system, I will let it like this. As it is, it's fine. Let's say that I want to add different data such as the administrative units, the IPCC data, and the digital elevation model. And when I set, and while generating a grid, I want to generate a systematic grid with a distance in meters of 2,000 meters. 2,000 meters of distance between the plots that will be within the grid. And I will not add any columns from other shapefiles. If I click here in Generate Grids, and a new window will pop up on the upper right side of the app. When you click Download Grid, a table, a CSV file will be generated with a grid. In this case, we have for all Cádiz, which is located in Andalusia in Spain, with a distance of 2,000 meters between plots. We have in total 2,293 plots, with all the information on administrative units, digital elevation model, climate, etc., etc. What you can generate as well is the data of the area for the country or for the province. And sometimes what happens is that the output that you want to generate is too large, and then you will need to export the data using the task panel on the code editor. One thing that needs to be considered when generating the grid, which will be generated and downloaded in form of a CSV file, is that this CSV structure needs to be adapted. In this case, the structure we mean the columns, the content in the columns. This will need to be adapted to the CSV structure of the collect survey. And I will very shortly explain how to find this CSV format of collect. Once you open OpenForest Collect, the tool that you use to design your survey, I will show you how to download the CSV structure that you need to adapt to the CSV that you just generated with the grid generator. So you go to the list of surveys, and here probably the survey that you have been working on appears. In this case, I will show you with this example. And if you enter the survey and go here on the upper right part of the panel, you can select Export Collect Earth Grid Template, and then you will be able to download the CSV with the structure. Now you need to adapt these columns to the grid that you just created with the grid generator. As you can see, the information is the same. You just need to move the information from column to column. This information is not there, so we will delete it. So starting with the ID. As the ID generated with the grid generator is very complex, maybe what we can do is to rename the ID. And as we're in Cádiz, we will just give it the name Cádiz 1, 2, and continue like this. And at the end, maybe just to make sure, you can check again. Just make sure that you follow the structure. And then the Excel will be like the grid, the CSV file with the grid will be ready to use in your Collect Earth project. Okay, now I will show how to use a Google Earth Engine asset to delimit the geographic area of our project when generating the grid. And for this, in the Google Earth, in the Grid Generator app, we will use the option Use Future Collection. For generating the grid within a certain geographic area, for example, we will choose the Doñana National Park in Spain, in Andalusia and Cádiz. We will need to download the shapefile of the protected area in Spain from an official website, such as the World Database of Protected Areas. If we go to the Protected Planet website, we can download the official GIS information of the Doñana National Park in Spain in shapefile. So we will download them and put them in our desktop in a folder called Doñana, for example. In the next phase, what we will need to do is to upload the future that we just downloaded as a shapefile in the Google Earth Engine repository through the Google Earth Engine code editor. For this, first of all, I created a folder in the assets sections on the left side of the Google Earth Engine interface, which is called, the folder is called Spain. And here we will upload the shapefile that we just downloaded. We select all the files, give them a name. I will call them D of Doñana, and we upload them. When we start uploading them, on the right side of the Google Earth Engine code editor interface in tasks, there will be a clock running. And when you finish to upload it, you can view the asset information. And first of all, you need to select that anyone can read, make the asset public so that later on we can use it in the Collect Earth Grid generator. If we refresh the website, the left side of the panel, we will have the D shapefile with the information on the protected area and the table ID that we can copy. And paste in our grid generator. Okay, so the other information that we need to include, the coordinate system, the information that we want to add, and the type of the grid. In this case, we will generate a systematic grid with 2,000 meters of distance between plots, and we'll go to generate the grid. When the grid is generated, again, you can click to download the grid. On the right side of the grid generator app, and we will have a grid that is delimited in the geographic area of the Doñana National Park with a distance of 2,000 meters between the plots. In order to see it, maybe what we can do is to drag. We can drag this CSV file in this grid, so to say, in Google Earth Pro. And here we will see that we have a grid with all the plots that have a distance of 2,000 meters between plot and plot. Perfect. So I hope this tutorial helped and it was clear on how to on how to use the Collect Earth grid generator, and until next time.